ICITY 2050, the fifth international conference on advances in computer science and information technology. On behalf of AIRCC, it gives me a great pleasure to welcome you all for the fifth edition of ACITY 2050. So we have planned three special talks to begin today's event. After the three special talks, we will have a short tea break, immediately followed by the talks in the morning session. After the lunch break, we have the talk scheduled for the afternoon session. We have a very busy day with so many talks from the following conferences. The main event VLSI is another parallel conference. Also, wireless and mobile network WIMNET 2050, artificial intelligence, soft computing and application AIAA 2050, and lastly, computer networks and data communication CNCC. Of course, computer science is the main focus of today's conference, and naturally the proceedings are published in Computer Science and Information Technology series. AIRCC Digital Library has a vast resource of papers. So we invite you to follow the proceedings, which will be loaded in the digital library along with the other papers. We recommend you also to cite papers from AIRCC journals and the conference proceedings. All of them are well indexed. Now, let us begin today's conference with an introduction of myself. My full name is Chandrashekhar. I shall be glad if you call me Sundar, as my friends do. I work as Professor and Dean, Research and Development Center at Wyld University, Chennai. It is a private university which is developing well with a good progress. I am also the India Chair of AIRCC. Naturally, I try to take part in is ACITY, DPP or VLSI, CNDC, VMNet, and also the soft computing conference. I welcome you all. Now, a few brief introduction about the invited guests, then I shall give a few technical remarks. I don't plan to give a very long speech. It will be a very short welcome speech only, but there will be some technical details pertaining my research. With that, I will conclude my talk. AIRCC takes great pleasure in welcoming our good friend and also the conference proceedings editor, Dr. Natarajan Meghanathan is a professor in the Department of Computer Science, Jackson State University, Jackson, Mississippi, USA, and he is one of the important leading AIRCC professors. So we organize conferences many parts of the world, and our goal is of course to impart knowledge and share knowledge with others. So the academic and the industry research collaboration center will be very glad to conduct these conferences in hotels like this and also in the university. He shall be giving a special talk after my lecture gets over. I also welcome Dr. Saroja Kanchi. We are waiting for her. She has not yet turned up. After Natarajan's talk, Saroja will also give a special talk. She is a professor in the Department of Computer Science, Kettering University at Michigan, USA. These two are the main invited speakers, and my talk is just a welcome talk. But I shall also give a few words on what do I do, what are my research like, without going into so much of technical details. I don't have the time. So these are my main research areas. If anyone is interested in knowing more, you are glad to interact with me during the breaks. This is my first and foremost research interest, namely linear and non-linear control own interest I developed on my own after my graduation. I did my doctorate in nonlinear control systems, so this is a totally a different field. Control systems is one field, chaos theory is a totally different field. What I am doing is I am applying what I have learned in control systems to devise new techniques for the chaos theory. Mathematical modeling of systems is a broad area. Under this broad area, I have discovered so many new chaotic and hyper-chaotic systems. During this talk, I shall give just one bird's eye view by giving one of the modeling I made, just one example only. Intelligent control interests me a lot, especially in control theory. There are lots of nature-inspired algorithms you can see in many IEEE conferences like the ant colony optimization, the bee colony optimization, PSO, particle swarm optimization. So many nature-inspired algorithms. Also neural networks, fuzzy logic. All these come under the broad umbrella of intelligent control. I am very interested in it. I am also doing some research in this. Computational science. This is related to the mathematical modeling. In addition to modeling, we also should have some numerical methods, some numerical computation. They go hand in hand. I'm also interested in this. And to give some idea about what I do, this is one of my recent papers. Four-dimensional hyperchaotic Rikitic dynamo system. The Rikitic dynamo system field of the earth, how it works. So it is a three-dimensional model. All the variables x1, x2, x3, x4, the states, they have some physical meaning. The first three states you have to read one base paper for understanding what they mean, and I don't want to go into those details. So what we did was, we took the Rikitic dynamo system and we converted it into a hyperchaotic Rikitic dynamo system of 4 dimensions. So we added a new state variable x4 and we converted it into a 4-dimensional hyperchaotic system, and we showed that system is hyperchaotic. trajectories can expand two different directions, in two independent directions. So, building a hyperchaotic system is more complicated than a chaotic system. And these chaotic systems and the hyperchaotic systems, they have a lot of important applications in devising crypto systems, secure communications, where you want to securely transmit a data. People encode a signal with a master system or a transmitter, which is one of the chaotic or hyperchaotic systems, and they decode from a receiver, which also makes use of a chaotic or a hyperchaotic system. This is one way of securely communicating the important data. And along that, we need to use some systems which are chaotic or hyperchaotic, and this is one of the mathematical models I have made with my research collaborators, Christos Wallos from Greece and Wyld Pham from Vietnam. So, a joint paper, this we published in Journal of Engineering Science and Technology Review 2015, a special issue edited by us, and we showed that the system is hyperchaotic for these four values of the parameter. How did we get these values? This is why I said computational science is one of my research interests. This involves a very long and extreme calculations with MATLAB, which is a scientific computation software. After performing rigorous computations with MATLAB, we got that for these values of the parameters, the system undergoes hyperchaotic behavior. A lot of properties are there. I will just say one property of this system, how it is different from the other systems. For all these systems, we do something called equilibrium analysis. Those who work in physics know the rest points that we get. Rest points or the equilibrium points. For that, we set the differential equations to 0. Look at the right hand side, set them equal to 0 and solve these equations. This is called a null Klein analysis. We do that for this system. If you set equal to 0 all the differential equations, the last differential equation gives you x2 equal to 0, right? To equate this to 0, you get C is a positive one, x2 is 0. If you substitute that in the third equation, what is the third equation? 1 minus In the literature, there are only a very few chaotic or hyperchaotic systems with these properties. We call those systems as systems having hidden attractors. This field was started by Russians Leonov and his colleague, I forgot his name. So Leonov, Gennady Leonov started this field, and he appreciated this work we have made because this is a physical system. You see, not an artificially constructed chaotic or hyperchaotic systems with these properties. So Leonov appreciated this work and he invited us to submit a paper for the special issue he was editing for Springer, European Physical Journal Special Topics, a special issue on multi-stability and hidden attractors. I am very glad to say the same collaborator I have extended this system into a five-dimensional system. A five-dimensional hyperchaotic critic dynamo system with three positive Lyapunov exponents. This paper just got published in July only in the Springer Journal, European Physical Journal Special Topics, EPJST. I invite you to read our articles. Volume 8, issue number 2, 2000 projection giving a different pattern. This is another projection. This is due to the second positive Lyapunov exponent. This is another different phase portrait of the four-dimensional system. This is just to convince you, but this is not the way we prove that a system is chaotic or hyperchaotic by just looking at the phase portraits. Some calculations we have to do called the Lyapunov exponents. So we calculated the Lyapunov exponents and showed that the system has two positive Lyapunov exponents, 1, 0, which is the Lyapunov exponent along the flow, and the last one negative. If you add up all the Lyapunov exponents, it will be a negative value showing that the system is dissipative and all the trajectories will converge to the strange attractor. This is about the technical part of my special talk. There are a lot I can say, but you can just understand that chaos theory is a new area brain. Also cardiology, people try to understand, those who had undergone a bypass surgery. Also in areas like secure communications, crypto systems, they are some of the vital applications of chaos theory in information technology, and also in economics, in finance systems, stock exchange. People try to do chaotic systems to understand. In chemical engineering, chemical reactors, starting from this B Z reaction, Bolzano Zavotinsky, sorry, Wiltauso Zavotinsky reaction. There are a good interest among the chemical engineers also in understanding the chaos that occur in chemical reactors. Lots of applications are there. You can read the survey papers. This is one of my recent books. Come to the last part of the talk. A book on differential equations, ordinary and partial differential equations. No chaos in this book. This is a simple textbook I wrote for the UG and the PG students, and this book is followed. Those who are interested can read this book for knowing the applications of differential equations. This is a research book that I published in spring. Chaos modeling and control systems design. Lot of good research papers are there for both chaos modeling and control systems design. Many of the things I said in the previous slides are explored in great detail in this book. You can read this book for more details. This is not a conference proceedings. This is a research book that I published with a few more invited authors. This is another research monograph, computational intelligence applications in modeling and control. I mentioned about the nature-inspired algorithms, the neural networks, fuzzy logic, genetic algorithms, and all. So all these and more techniques are explored with applications on modeling, how we can model the various engineering problems with the nature-inspired algorithms. Some optimization techniques are there, and also with the control. This is another book. And the last book that I published with a lot of effort. This was the most difficult thing in my life. Publishing this IGI book, Professor Natarajan announced IGI book in and everything they will count. The preface that we write, it should have between these words, that is, I don't remember the number, 2,500 to 3,000, or they have a limit. Within that, we should come each chapter, they rigorously check the English and the content, the figures, everything. So very, very tough. They made our life more difficult. Writing the chapter was easy, but editing it took us a lot of time. IGI has invited me again to write another book, but no such plans. It is a good book. I should not say, but you can read it, then you will agree with me that it is indeed a good book. I don't like promoting my book that way. Advanced intelligent control engineering and automation. So this is a combination of the previous two books with more long chapters, because IGI has a requirement that all chapters should be very elaborate, very long chapters. So they are full papers, very good papers are there. This book is very nicely produced. It's a very big book. So production wise, content wise, it is a very good book. As the editor and also one of the authors of this book, I shall be glad if you read this book. With this, I conclude my special talk. I sincerely hope that all of you take good use of this conference. You see, you can easily publish a paper, a journal, after a few reviews. You are presenting the paper in this conference. So what is the difference? The difference is this. By interacting with the other authors, by interacting with the experts in any conference, you get some more research ideas. Also, you get some more exposure in the other areas. I shall conclude this talk with a very inspiring remark by Henry Ford. What he says is, getting together is a beginning. Keeping together is progress. Working together is success. Okay, so we are in the first stage, getting all of us together. We have made a good beginning. So as the conference proceeds today, let us all keep together, that is, following each other's talks, and at the last stage, work together. That is, even after the conference, you can be in touch with the other friends or the speakers. I welcome all of you for attending this conference. The morning session will be entirely chaired by Professor Natarajan. I shall share the afternoon session only. Make best use of this conference. Okay, thank you all. Have a great day. Fine.